So we generally have two ways of asking for any updates from a server. These methods are popularly known as push-based mechanism and pull-based mechanism. So in today's video, we are going to explore those mechanisms. Now with push-based communication, you are not constantly asking for updates, but you are subscribing server for new updates. For example, whenever your friend likes or comment on your photo, you would get a push notification, and that is not happening because your mobile is asking for constantly new updates, but the Instagram server would push a message to your mobile device, and your mobile device UI would render that as a push notification that your friend has liked your photo or someone has commented on your photo, and then you can click on that notification and do whatever you want. Now this kind of communication is called push-based communication because server is doing the push of data to the client, and client not asking it for explicitly. And another example of this is SSE, that means server side events. Server side events are a HTTP based mechanism for pushing data. So in normal HTTP calls, what would happen is you would create a request via your client and server would send you some data, and then your connection would be closed. Okay, but in case of SSE, server would not immediately close the connection after sending the response, but it would persist the connection until it's have more updates for you. For example, if you have subscribed for a cricket score, okay, let's say we are going to have IPL the next month, and you have subscribed for a match updates. So your mobile device would make a connection to the server, and that connection would be persisted in the server memory. And whenever we have any update regarding that match, let's say someone hit 100, sorry, 100 would be too much for a T20 match. Let's say someone hit 50, then it would update that update on your client device without explicitly asking you for the update, because you have subscribed that SSE channel. Now this is a half duplex kind of a mechanism. What half duplex means is only one side can communicate, okay, that is the server in this case. So once you are done with sending the request to the server, client can't send any data further to the server, it is blocked, but server can send any amount of data and for as long as it wants, okay, until you haven't configured any kind of timeout on your client implementation. So a more generalized example of this would be an FM system. So whenever you tune a FM radio channel, only jockey can broadcast the messages and you can't. So you can't just directly talk to a radio jockey. A radio jockey can talk to all of its subscribers. So that is an example of half duplex communication. Then we have WebSockets. Now, WebSockets are full duplex. Either side can send messages and either side can receive the messages, just like your telephone communication. Like if two friends are talking to each other, they both can talk at a moment, and they both can hear for a moment. That would make sense, because if both of them are here, there is just awkward silence that happens with me. Okay, let's not talk about that. Then we have these PubSub models. So PubSub is not a protocol like WebSockets or SSE. It's more like a server architecture. So in PubSub, what would happen is there would be a servers and there would be a set of subscribers that are subscribed for a particular topic. So what topic is just a normal string. Okay, so it's just a label that I'm using. Topic is not a fancy thing, or topic is not a database or something. It is just an identifier. Let's say if we have 5 subscribers and those 5 subscribers are interested in any updates regarding Spider-Man, then they can subscribe this topic to Spider-Man, and whenever the server has any information or any update regarding this topic Spider-Man, that it would push that data to all the available subscribers, either it is 400 or 4,000, that doesn't matter. And that's what the PubSub model is. But we would not dive into this, because PubSub has a whole spectrum of implementation details that we can worry about, but we are not going to talk about that today. Then we have webhooks. So webhooks are neither the protocol, neither the architecture. It is more like a workaround, I would say. So webhooks are only applicable in case of server to server communication. Now server to server communication means to publicly available servers. Okay, so for example, if you have this Shopify server and you have this CRM server for your organization. So whenever you got a Shopify order, your Shopify server would hit to your CRM server that, hey, we got a new order, and then your CRM server can process that order accordingly. Now they both have to be public. Okay, like in this case, this CRM server should be public, because if it is not public, then we don't have public IP or a domain for this server, and we can't contact it directly. So you can't just make your phone as a publicly available server, because your phone has NAT issues, network address traversal. We would talk about this topic on some other day, but for use case of webhooks, you need publicly accessible servers. And webhooks are kind of a callback mechanism, that when someone happens, hit to this URL. So it's kind of an event driven system you can build with webhooks. Then we have these pull based communication. So that what I said you in the start of the video, that we have two mechanisms: push based communication and pull based communication. Now pull based communication happens when client is explicitly asking for new updates from the server. So what would happen is, client would create a request. Let's say if you are asking for stock price of Reliance, like what is the price that Reliance stock is trading for now. So what would happen is, client would make a request to the server that what is the price of this Reliance stock, and server would give him the data. Let's say if it is trading at 2300, okay, then it would immediately close the connection. Then client would create another request after some time, or it can also do that immediately, because a client needs fresh information about the Reliance stock. That's why they are trading the stock, so that they have the fresh, like the latest value of the stock, so that they can make those transactions and make some profit. But now what is happening is, you are constantly hitting the server again and again and creating unnecessary overhead, because it is not necessary that for a span of 5 minutes there would be a fluctuation of price in Reliance stock, because these stocks are not so volatile like penny stocks. So in 5 minutes, so you can imagine that how much requests you can make in that span of 5 minutes. So what we do is, after creating, like after a call, what we would do is, we would make the another call after a certain interval. Let's say we have set the interval to 20 seconds. So then we are going to make a request in every 20 seconds from our client. Okay, so in every 20 second, server would get hit by a client, and it would give whatever information it have. So that's a pull based mechanism. And an example of this would be HTTP polling, that I gave you an example of, that where the client is creating repeated request after a certain intervals. And then we have HTTP long polling. So long polling it's like sort of a polling, but it is the interval part, the timeout part would be implemented by server and not the client. We would talk about the HTTP long polling mechanism in this video, but later. Okay, so let me just give you some examples so that we can understand it more clearly. So first we would dive into the pull based mechanism, because I am biased towards push based mechanism and it is better. So I would show you the example later. So first we would go with the pull based example, and I have this example open in this tab. So let's say you are a trader and you are asking for Reliance stock price, and we have three major components in this diagram. For the first one is client, and the second one is the server, and the third one is the exchange. So we are not going to dig deeper in the implementation of communication between server and stock exchange. We don't know, like we don't have to care about whether it is happening by a push API or pull API. That is not the scope of this diagram or this example, so you can just clearly ignore this. The scope of this diagram is the communication which is happening between client and server. So let's say in this example, the clients first ask that give me some information about the Reliance stock price, and the server would return that it is trading at, like, say 2100. Okay, then after getting this response, the client would wait for a certain time interval. Let's say we have set interval to 30 seconds. So after 30 seconds, it would again ask the server that do you have any updates for Reliance stock, and if the server have the updates, then it would send it the updated value, or it would send it the previous value, that the value that it has sent in the previous request. Okay, so in this diagram it is showing that we don't have any updates for the server. And then let's say during the next interval, okay, so the between second and third API call, Reliance stock short by 100 rupees, and now it is trading at 2200. Okay, now but the client would make the request after the end of interval, so he's unaware of that the price has shot by 100 rupees and now trading at 2200. And now in the third request itself, it would get the information that the Reliance stock has shot up. So to get a minor update of this minor update, we have to make like 3 requests. Okay, and the middle request was unnecessary, like it just create an overhead on the server, and it was useless, I would say. Now this is a simple example because it is not harmful, because your stock price is just getting increased. But see, in a real business problem, like what would happen is, for example, if you are a trader and you want to sell the stock, okay, and the last trading price is now 2200. Okay, and let's say your interval is quite big. Let's say your interval is 1 minute, so you are not going to get any updates in 1 minute of time span. And let's say on a 20th second of your HTTP, after your HTTP call, the server's price shot up to 2200. Okay, now is the price that you can sell it, but after 30 seconds, okay, so that is the 50th second after your HTTP request, the stock price again goes down by, let's say, 150 rupees. So now it is trading at 250 to 2050 rupees. So now you would book a loss, because you missed the chance of selling the stock on a higher price. So that is the latency that we would face with this polling mechanism. So the main cons of this would be this additional latency and unnecessary request that is making to our server. Okay, so here comes my favorite part. So now we are going to explore the push based approach example. So same example, we have this Reliance stock that we want to get updates for. So we would ask the server that, hey, do you have can you tell me the price of this Reliance stock? Then server would send us the data that, hey bro, it is trading at 2100. And let's say because we have this connection persisted, we are not making any repeated calls to our server, and whenever the server price would shot up, let's say by 200 rupees or 100 rupees, we would get an instant update. That is what is we are showcasing in this example as well, that whenever we are getting any updates, we would send you that, buddy, its price has shot up by 100 rupees. So in the regular APIs, you are not going to see this kind of English that I'm using, that buddy. But it would be a JSON kind of a response. You can send the delta values and you can send the real value of the price as well. So you can you can send the whole new data, like what is the updated state of the data, or you can just tell about the transition that it has made. So that was a example of push based APIs, and it is pretty simple, that it is more efficient than pull based approaches. So let's let me walk you through the pros and cons of these two mechanisms. So now we are going to discuss the pros and cons of push and pull based mechanism. So we would start with the pull based mechanism. Now the pros would be, it is far easier to maintain than push based APIs, because while implementing push based APIs in a server environment, you need a whole set of new implementation. You need to persist the connection. You need to know which server is connected to which device is connected to which server if you have a horizontally scalable system. And it is quite easy to implement the pull based mechanism, because you just need to constantly hit the server after the certain interval. Now because we don't have any persistent connection in the memory of server, it is less overhead from a memory perspective on our server. Though we are going to have overhead of unnecessary connection, but that the memory part would be a savior in this case of pull based mechanism. Then you have this cognitive load of deciding what should be the interval of this interval that you are going to put between your calls. Now this interval can change over the use case, depends on how sensitive the data is, like how more frequent you want it. You can't just repeatedly hit the server in every 100 milliseconds, say. It can depend on the use cases. For example, for a cricket match, you would say in a matter of 3 seconds or 4 seconds, because that would be the average time it would take to bowler bowling and the cricketer hitting the shot. So that really depends on the use case. Now cons would be that delayed updates that we saw in that example as well, in the Reliance stock price, because you have this interval. You are not going to get the updated values instantly that we would get in the push based mechanism, and then you have this many server hops in the system between. So it is not a direct connection between your client and your server, because we have this whole plethora of topological components, I would say, network switches, network routers, API gateways, load balancer, and whatnot. And every time you are making a HTTP request, you are going through all of this again and again, and that creates unnecessary overhead on your network and increases latency by a good factor. Okay, so next con would be, so we have run out of cons with the pull based mechanism. So let's dive now with the push based communication. The pros would be, we are going to have no significant delay in the updates, because server is pushing the data as soon as it get from the source. So let's say whenever it is getting the price from the stock exchange, it is pushing all the subscribers that want the data regarding a certain stock. Let's say it is Wipro or TCS or Reliance or whatever the stock price you are betting on. And the pros would be, because we are going to have less number of server hit, the server would be more relaxed, the network would be more relaxed, because there is no bombardment of connection in every, say, 5 minutes or every 5 seconds. Actually, the connections are not synchronized, so I can't say that it is happening in every 5 seconds. We have this synchronized set of connections, so server would constantly have a stream of unnecessary traffic. And the third thing would be, you can create near real-time experiences like instant messaging, group chat systems with these kind of push-based APIs. You can create your own typing indicators that you see in the Instagram and the WhatsApp with this kind of communication mechanism using WebSocket and server-side connections. Now the cons of the push-based APIs, for certain use cases like a group chat or chatting-based systems, it would be quite difficult to horizontally scale the system, because then, for example, you have this server, okay, and we have, so for example, if this part is a server and this is a client 1 and this is client 2, and you have this set of 2 servers, okay, this is S1 and this is S2. and they both are connected to different servers. So now you need a middleware mechanism to bypass message coming from this client to this client, because they are on a different server, and you need to do that in real time. So you have to take care of that as well. So this system, I would not say that it is not horizontally scalable. It is, but it is far complex than pooling based mechanism. You can think of vertically scaling up your server, but then you would have this case of hitting the limit of open files at a time that Linux and Unix based system impose you. So you can't have a certain number of simultaneous connection on a Linux box. That is a matter of fact. And so that is the con of this server. And then we have, because we are going to have persistent connection, we are going to have them in our memory. So that would create a memory overhead on the server. But that problem can be solved if you have like right capacity on your server, and you can smartly tweak your server and tweak your implementation to get the maximum output from your server. Now, the third would be, it is far complex to code this as well, because you have like many components out there. That the example we saw in this case, like this is client 1, this is client 2. Then you have to create a middleware microservice if you are going to have a microservice based architecture, or you need some cache server that would do that would broadcast the messages between the servers. You can use Redis, or Netflix has this mechanism called Zool push around this mechanism. So it is far complex to maintain, to implement these features comparing to the polling mechanism. But everything has its own cost, so you just can't expect real-time experience without any cost. You have to do the extra work. Now, use cases would be if you need real-time communication, if you want to push updates in the system, you want to notify, send promotional content to your user, you should go with the push-based API. And if you don't have much time and you want an easy and simple workable implementation, you should go with polling. Now, I'm not saying that like it is an industry practice to of these use cases. It depends completely upon your use case and what trade-off you want in your system. You want speed or you want simplicity. Okay, so that's up to you. Okay, so in the starting of this video, I told you about this long polling. So long polling is sort of polling, but it is maintained by server and not client. So in polling, as I said, that server would make a connection and would get a response and wait for certain time, and then would make the another request. But in case of long polling, what would happen is you would make a request, and if the server has some updates for you ready, then it would immediately push that data on the HTTP request and would close the HTTP request. But if it doesn't have any updates for you, it would persist your connection for a certain time interval. Let's say if the time interval is 60 seconds. So if the server don't have any data for you, it is going to wait for 60 seconds. That means that, because that can give you a more push sort of a experience, because now whenever the updates are available in the server would immediately push them on your client devices. But there would be an overhead of creating the new connection, because as soon as the server has the data for you, it would push the data and would close the connection. So that is the thing with long polling. But long polling can be a great substitute of WebSocket and SSE if you don't want that kind of complexity in your system. But it would introduce the overhead on your network, because we have a plethora of topological devices that are going to hit by these HTTP long polling requests. To showcase you how these push and pull based communication work, I have prepared a demo application for us. So as you can see on the screen, we have 3 tabs open. The first one is a server tab, push and pull, and the second and third tabs are different clients we are going to use. One would be the push based client and another would be the pull based client. So before starting, we are going to start our server. So let's see what options we have. So we have option to set the port, but I'll keep it to default port for now. So let's start the server. So this server is simulating a kind of a stock exchange that we have discussed in the previous section of the video. So it is logging the latest stock price of some random stock, let's say Reliance or Wipro or whatever stock you believe in. Then we have this client, and this client would be and let's see first of all what options we have. So we have an interval that is going to be the poll interval, and then we have this flag, pull or not. So if we invoke the command with the pull flag open, that means it is going to be a polling based client, and if we didn't, that means that it is going to be a push based client. So let's start a pull based client first. Okay, so I'll keep the interval at 3 seconds just to showcase you how unnecessary request a poll based client can make. You can set this interval to whatever value you want, but just to showcase you and just to give you a narrative on how efficient the push API is, I'll walk you through. Okay, so we have established the connection and we got the response as 2034 as the latest stock price, but the latest stock price is like moving rapidly or like fluctuating between different values, but and you can see the explicit lag like we have in the pull based client. Let's see how our push based client would perform in this scenario. Okay, so we got a new client. So we got 2 pushes. So as you can see, as you can see the synchronization of stock prices between push client and the server, but you can clearly see the lag in the pull based client. You can also notice the unnecessary request we are making to the server that is returning us the same value of the stock, whether it is moved up or moved down, whatever. Code for this application is available on the GitHub. Please hit the star button on the GitHub repository. That would give me some more motivations to prepare these kind of application in future for our future videos. And please like this video, share this video, write your comments down if you have any suggestion about the content or the video quality or whatever, or my speaking style as well. Please give your precious feedback. That would help us to make better videos and help you better with system design. Thanks for watching the videos.